Tutorial 4. Number 1. Glycerin flows in a 25 mm diameter pipe at an average velocity of 0.3 meter per second. So we got the diameter 25 mm at an average velocity 0.3. So velocity equal to 0.3 meter per second. If the density of glycerin is 1260, density glycerin is 1260 kilogram per meter cube, and the viscosity glycerin equal to 14.9 10 negative 5 Newton second per meter square. Determine whether the flow is laminar or turbulent. So Reynolds number equal to rho ud per mu. The garden hose attached with a nozzle is used to fill a 20-gallon bucket. The inner diameter of the hose is 1 inch. So diameter 1 inch. And it reduced to 0.5 inch at the nozzle exit. So dia besar, kecil macam tu. So D equal to 1 inch. And we have the nozzle. D equal to 0.5 inch. If the average velocity in the hose, so velocity is 8 feet per second, determine the volume and mass flow rate. Volume, mass flow rate. Okay. Of water through the hose, take the density of water. Density of water equal to 62.4 volume flow rate. Volume flow rate Q equal to AU or UA. Okay, so the question only asked at this point lah. Because the hose determine the volume and mass flow rate of water through the hose. So sini lah, bukan dekat nozzle Okay, so you can use this equation Q equal to AU. Q equal to A pi d square over 4 times with U. Okay, so mass flow rate equal to rho Q. A desktop computer is to be cooled by a fan. Flow rate is 0.3. Determine the mass flow rate of air through the fan at a high elevation of 3,400 meter where the air density is 0.7. Okay, hash 3,400 meter. Air density rho air equal to 0.7 kilogram per meter cube. If the average velocity of air is not exceed average velocity U air, tak boleh lebih 110 meter per minute, determine the diameter of the casing of the fan. second is D. M equal to rho Q. So we got the density 0.7 kilogram per meter cube, and the Q is 0.3 meter cube per minute. So meter cube, so 0.21 kilogram per minute. Okay, so 1 minute equal to 60 seconds. 0.21. Okay, apa? 0.0012 35 kilogram per second. Q equal to AU pi D over 4 time with U D 4Q over U pi. Okay, so diameter 0.0589 itu. Express the Bernoulli equation in 3 different ways using A energies, B heat, and C pressure. Number 5, state 4 major assumptions used in the derivation of the Bernoulli equation. So now number 6, water at 15 degrees Celsius with density 999.7, viscosity kilogram per meter second, is flowing steadily in a 30 meter long, 30 meter, and diameter 4 cm, stainless steel. Q equal to 8 liter per second. So determine A, pressure drop, and D is the head loss. Next number equal to rho UD over mu. So we have the density, we don't have U. So Q equal to AU. So Q, we have Q. We have A, and then we don't have the U. So U equal to Q over A. Okay, 8 liter per second. Alright, so you need to, because all the information in an SI unit, then you need to change 8 liter per second to meter cube per second. 1 liter equal to 0.001 meter cube. 0.008 lah meter cube per second. Okay, so U equal to 0.008 meter cube per second divided by A. So we got the diameter, where's the diameter? 4 centimeter. Pi 4 times 10 power on negative 2 meter pi d square over 4. draft pipe into volume flow, use the Moody diagram. But kita ada Reynolds number. We don't have E over D. So before we got E over D, we need to find E. E over D equal to 0.1.5 times 10 negative 5 meter divided with the diameter, kan? Zero point 0.0158. Hegel for lamina, Okay, dasi delta P kita nak cari pressure drop, kan? So delta P equal to F L over D rho U square over 2. So 238.524 kPa. 8B, SL equal to 3 semula. F L over D U square over 2G. So 0.0157 times with 30 meter over 0.04 meter U square 6.366 meter per second over 2 K. In an air heating system heated at 40 degrees Celsius, temperature drop 40 degrees Celsius, V 105 kPa, rectangular 0.2 0.3. Smooth surface, smooth surface. Zero, at a rate of 0.5 meter cube per second. So determine the pressure drop and heat loss through a 40 meter long, L is 40 meter, section of the duct with the viscosity 1.918 10 negative 5. So first you need to calculate Reynolds number. Reynolds number rho UD over mu. So now we have the rectangular. So D dah berubah. D dah situ 4A square over O ni 2AB over A plus B. 0.287 kilopascal meter cube over kilogram. Okay, ya. Google ni macam apa dah, hebat. Okay, 40 degree Celsius tukar kepada Kelvin. U equal to Q, mana Q? 0.5 meter cube per second divide with the area. 0.2 right. Okay, substitute in Reynolds number. Okay, so bigger than 4,000, so tu bulan lah. Okay, for hydraulically smooth pipe, epsilon equal to 0, but dia kata smooth surface kan, so epsilon equal to 0, so F equal to 0.3164 over Reynolds number power of 0.25. So F equal to 0.3164, 0.25. Sebab itu bulan kan? Okay, number 8 Okay, oil density 888 kilogram per meter cube, viscosity 0.8, so D 5 centimeter, 40 meter long. The pressure at the inlet and outlet are measured to be AP inlet 745 kilopascal, pressure outlet 97 kilopascal. Determine the flow rate of oil. Okay, so Q. If the flow is laminar, discharge in the pipe for laminar flow, so Q equal to delta P pi d power of 4 over 128 mu L. Okay, the pipe flow in figure 2 is driven by the pressure and in the tank. See the diagram 2. What gauge pressure at P1? 0.1, 0.2. 10 meter. 60 meter. Air. Tak betul ni. Okay. Gauge pressure. So dia nak kat P1 ni, what is gauge pressure at point 1 to provide a 20 degree Celsius water flow rate. So we have the Q 60 meter cube per hour, and viscosity of water at 20 degree Celsius is 0.001 kilogram per meter second. First, we need to calculate the Bernoulli equation. Second, because include piping system, and then we need to calculate roughness, heat loss. Okay? So before heat loss, first you need to calculate Reynolds number to determine either laminar or turbulent flow. Okay, so as usual, Reynolds number, rho ud over mu, we have mu. So D, smooth pipe, 5 cm, smooth pipe U, but we have Q, so Q equal to AU, U equal to 60 meter cube per hour, A, 5, D is D, 5, 0.05 meter over 4. Okay, substitute in Reynolds number equation. So turbulent So F 0.012, and ini HL equal to FL over D U square over 2G. P1 over rho G plus Z1 okay. Now because we have piping, then we also have heat loss kan, so plus with heat loss. This one is very big tank compared to diameter 0.05 kan, very small piping, so the water flowing very slow, going down very slow, maknanya gerak bawah ni very slow, and then U1 equals 0 nearly 0 at ni point 1 this one is point 2, refer to figure 2. Alright, P2 for gauge, P2 is ATM, so for gauge P2 ATM equal to 0 0 gitu. And then we select the datums. Okay, let's say we select this one as a datum. So Z1 equal to 0, Z2 equal to 70. Okay, 0, this one equal to 70 meter. So P1 over rho G equal to U2 square, 8.48 meter per second square over 29.81 meter per second. Apa ni? Plus with 70 meter plus with berapa tadi? 14669 meter. Darab dengan rho G. So kita cancel yang ni. Okay, water is pumped through a pipeline to a treatment plant at a rate of, okay, kita ada Q 3.68 meter per second. The 5 feet diameter Suction line is 3,000 feet long. In discharge, okay, ini adalah suction okay, untuk discharge diameter is 3 feet and long is 1500. The total heat loss, alright, so P1 350. Oh, so which is 15 feet higher than entrance. So gambar kan, wah insyaAllah. So 0.2, 0.1. So sini D5. So sini D3. P2, 0.2, P1, 0.1. P1 over rho G plus U1 square over 2G plus Z1 equal to P2 over rho G plus U2 square over 2G plus Z2 plus heat loss. So this one is a dead terms. So Z1 equal to 0. We got the P1 already. We don't have a U1. We need to calculate the P2. We also don't have a U2. Z2 is 15 and HL equal to 56. Alright, so U1 equal to Q over A1. Okay. 3.68 meter cube per second. Divide by over A1 equal. Okay, A1 pi D1 square over 4. So pi D, so 1.524 square. 1.84 2 square. So U1 equal to 0.017 meter per second. Okay, so A2 so we have P1 350 kPa. We have a U1, this one U1. P2 we need to calculate. The question asks us to calculate a P2. We have a U2 5.603. Z2 is 15. Convert per meter lah macam biasa. And we have the HL 56. So 56 convert to meter So nanti at the end you got P2. Water at 70 flow by gravity, flow a large reservoir, large reservoir at high elevation to a smaller one through a L 2-inch diameter cast iron. Okay, ada cast iron dulu, hati-hati. Piping system that include 4 flank. Ada 4 flank elbow. One well-rounded entrance. Satu. Sharp each exit. Ada satu. Fully open gate valve, taking the free surface of the lower reservoir as a reference level. Determine the elevation Z1 of the higher reservoir for a flow rate of 10 P1 over rho G plus U1 square over 2G plus Z1 equal to P2 over 2G plus U2 square over 2G plus Z2 dash HL. Okay, this one zero sebab datum we set as a datum. Okay, sebab ada flank semua ni, ada exit ni, fully open gate valve. Oh, ada fully open gate valve. Oh, okay. Lepas tu fully open gate valve, sharp exit. Okay, exit ni ada sharp exit ni. Well rounded entrance. Okay, entrance 0.26 millimeter. Okay, millimeter to feet. Okay, kita akan dapat 0.00085 feet. So U equal to Q A feet cube per minute. Okay, 1 minute 60 second Okay, pi 2 inch, okay, 12 inch 1 foot, pi d square over 4. Rho U D over mu. We have U so kita dapat viscosity dia at 70 degree Fahrenheit 2.3556 pound mass over feet hour. So epsilon over D, epsilon 0.00085. So 5.1 negative 3 Okay, so refer Moody diagram tadi. F equal to 0.029. PATM 0. PATM 0. Dia kata very large. Refer equation refer question. Large reservoir. Large reservoir ni maknanya besar kan. So pergerakan dia slow sebab piping ni kecil je. So 0. So Z1 equal to HL. HL total equal to FL over D plus total KL U square over 2G. Okay, so 1 KL 0.03. Kena rounded ni 0.03. Standard flank elbow. Flank, okay ni 0.3 ada. Elbow 0.3. Kit buff sigma. Okay, sigma 1 lah. Exit lah. Okay, 0.2 H1 0.03 0.3. Total KL equal to HL 120 feet. HL equal to 20.47 feet.